So the first step when using bottoms up is you got to find out what your factors need to multiply to by multiplying the first and last coefficient. Second step is to find out what they need to add to by looking at your middle coefficient. The next step is to figure out what two numbers, or find the combination that will multiply and add to give you those particular numbers, to give you that particular product, to give you that particular sum. You write these numbers in binomials and then divide by the leading coefficient. Second to last, well, I guess this is third to last. You're going to simplify if you can. If you can reduce the fraction, reduce them. You're always going to see if you can reduce the fraction. This means if you still have a denominator, if it's still in fraction form, that denominator is going to move to be a coefficient of x. You need to make sure after you move that bottom up, does your first, outer, inner, last, or does your double distribution actually check out? Example? It says example 4. It's continued on from whenever we did greatest common factor, so we could just write example. We're going to factor this trinomial using bottoms up method. First step is to figure out what you multiply to. In order to do that, you have to take your first coefficient times your last. So I'm going to see what multiplies to 12. And then what adds? What adds to give you 13? Because that's your middle coefficient. I'm going to use those when writing my binomials. Since the variables is x, I'm going to make sure I have x in the first spots. I'm going to put plus 1 and plus 12 in parentheses. But then I'm going to make sure I divide by the leading coefficient. And the leading coefficient was 2. In the next step, I reduce. I cannot reduce the 1/2, but I can reduce 12 halves. And it's the last step that if I still have a denominator, that's going to be moving up as a coefficient. Leaving me with 2x plus 1 times x plus 6. And let's just quickly check. Sometimes all you need to do is multiply your first and your last. 2x times x does give you that 2x squared. That kind of checks the whole bottoms up deal. Did you move your bottom up? Because those first terms should get you back. And then your last terms, 1 times 6, should get you that last constant. ACT-wise, it's kind of all you need to do whenever you're checking your work. Definitely check to make sure your first and your last check. All right. Again, it says example 5, but you could just put example by it. This one's actually tricky. There's 2 options that are pretty close. 1 and -6. There's also -2 and -3. So then it's like, wait, which one is it? -2 and -3 multiply to be a +6. So it's 1 and -6 to give me the right combination. This is actually the hardest polynomial, or the trickiest trinomial. 1 and -6. Multiplying by taking your leading coefficient times your last, 1 times 18, multiplies to 18, but needs to add to give me the middle coefficient, -9. So I'm going to put those in binomials. And by the way, since we're dealing with y's, if you're working ahead, be sure your y's are written in your binomials. I put -6, -3 in their spots, and I divide by the leading coefficient of 1. I reduce. If I still had a denominator, I would make sure that it moves to be a coefficient, but since I do not, this is where I stop. We're supposed to multiply to 14, but add and give you 15. The possibilities for 14 are either 2 and 7, 1 and 14. So if you got 2 and 7 together somehow, that only gets you to a 9. But 1 and 14, if you added them together, they do get you 15. So this binomial, and by the way, we're dealing with r's, which sometimes we get in a groove of x that we forget to just recognize the variable. 14 and 1 is our combination. And I'm going to divide those by the leading coefficient, which is 1. Maybe unnecessary. So if I go through and list my factors, -2, +6, I've got q -2, q +6. You could take the option of dividing by the leading coefficient 1. We've got 2 more. So we will have to take note of that leading coefficient. So I'm going to have to multiply that first and that last to figure out what I need to multiply to. 3 times -8, that's what I'm multiplying to, -24. And then I'm going to be adding to that middle coefficient. Off to the side are all of your possibilities to get a 24 as a product, but how can I get a 2 between them? So you're looking for the difference of 2. 4 and 6 would get me a difference of 2 if the 4 was negative and the 6 was positive. That's my combination. Divide by your leading coefficient. Reduce. First fraction cannot, but the second does. 6 divided by 3 is 2. So this is the point where I definitely need to move this denominator up as a coefficient. And let's just check the first and the last. 3x times x does get me a 3x squared, and -4 times 2 does get me back to that -8 as the constant. Last one, 4x squared plus 3x plus 1. So, taking 4 times 1, if you've already done this, what multiplies to 4 but has a sum of 3? So because this didn't check out, it's not called no solution, it's called prime. When you cannot break up a number, when you can't break up a plain number, we call it prime. When you can't break up a polynomial into factors, you also call it prime.